John Many imparts making learning accessible.
You are welcome to John Many Imparts. In this lesson, we would be focusing on how to simplify algebraic expressions. So without wasting much time, let's get started. In this task, we are to simplify the algebraic expression 2x plus 8 plus 3x plus 1. 2x and 3x are like terms because they all have the variable x with constant coefficients 2 and 3, respectively. Hence, we can sum their coefficients and then multiply the result by the common variable, x. Moreover, 8 and 1 are like terms because they are both constant terms, so we can also combine them to form one single term by summing them up. 2 plus 3 is 5 times x, we get 5x. 8 plus 1 is 9. So we get 5x plus 9 as our answer. To simplify this expression, we need to look out for like terms. X squared has no like terms, so we write it and move on to the next term. The next term is 7, and it has one like term, that is, -1, so we can combine them as one term. Now we write the remaining term, that is, minus 3x. 7 minus 1 equals 6, so we get x squared plus 6 minus 3x. We can choose to leave our answer here, or rewrite it in the form of a quadratic expression of the form a x squared plus bx plus c. And we get x squared minus 3x plus 6. How would you simplify the algebraic expression -3x plus 3y minus 2x minus y plus 4x plus 10? The -3x term has two like terms, negative to x term and positive for x term, so we can combine them to get one term. Furthermore, the 3y term has one like term, and it is -y, hence we can group them. The constant term, 10, has no like terms, so we can write it. -3 minus 2 plus 4 is equal to -1. Minus 1 times x is equal to minus x. +3 minus 1 equals 2. 2 times y is to y. Next we write the constant term, 10. Let's move on to the next example. In this example, we have two x squared y terms and two xy squared terms. First, let's group the x squared y terms. Next, we group the xy squared terms. 5 plus 3 is 8. 8 times x squared y is 8x squared y. 5 minus 3 is 2. 2 times xy squared is 2xy squared. Let's try another example. Not all the time we get x and y as variables in algebraic expressions. However, the procedure in which we solve them remains the same. For instance, 3p minus 4q plus 8p plus 6q is an algebraic expression. There are 2p terms and 2q terms. Grouping the p terms, we get 3 plus 8 all times p. And combining the q terms, we get -4 plus 6 all multiplied by q. 3 plus 8 is 11. 11 times p is 11p. -4 plus 6 is 2. 2 times q is to q. A positive number times a positive number gives a positive product. For instance, +4 times +2 gives +8. However, a positive number times a negative number results in a negative product. For example, +4 times -2 is -8. In addition, a negative number times a positive number gives a negative product, as in -4 times +2 equals -8. Finally, a negative number times a negative number gives a positive product. A typical example is negative 4 times negative 2 equals positive 8. These rules also apply to division. When multiplying algebraic expressions, it is advisable to multiply coefficients and constants first before multiplying variables. Considering the constants, we get 5 times negative 7 times 9. Now we multiply the variables and we get x times y. 5 times negative 7 is negative 35. Negative 35 times positive 9 is negative 315. X times y is xy. Focusing on the coefficients, we get positive 15 divided by negative 3. Next, we consider the variables, and we get y exponent 3 divided by y exponent 2. Positive 15 divided by negative 3 is negative 5. From indices, when we divide numbers of the same base, we subtract the exponent of the divisor from the exponent of the dividend. The exponent of the dividend is 3, and that of the divisor is 2. Therefore, 3 minus 2 is 1. Y exponent 1 is y. To solve this example, let's consider the coefficients first. Now we focus on the x variables. Next, we concentrate on the y variable. Positive 6 times negative 4 is negative 24. Negative 24 times negative 1 is positive 24. X and x exponent 2 has the same base, x. X is the same as x exponent 1. Since x and x squared are multiplying, we add their exponents. 1 plus 2 is 3, so we get x cubed times y. To solve this example, let's first consider the numerator. Next, we do the same for the denominator. Positive 3 times negative 2 is negative 6. Negative 6 times positive 6 is negative 36. X exponent 5 times x equals x exponent 7. Y times y exponent 5 equals y exponent 7. Negative 3 times negative 2 is positive 6. Positive 6 times positive 3 is positive 18. X squared times x squared is equal to x exponent 4. Y times y exponent 3 is y exponent 4. Negative 36 divided by positive 18 equals negative 2. X exponent 7 divided by x exponent 4 is x exponent 3. And y exponent 7 divided by y exponent 4 is equal to y exponent 3. To solve this example, what we need to do, first of all, is to distribute the 5. 5 times x squared is 5x squared. 5 times 2 is 10. Times x is 10x. X times x is x squared. Times 3 is 3x squared. 3 times negative 7 is negative 21. Times x is minus 21x. At this point, we can combine like terms. 5x squared plus 3x squared equals 8x squared. 10x minus 21x is negative 11x. Let's try one more example. Let's first distribute the 3. 3 times negative 2 is negative 6. Times x is negative 6x. 3 times 4 is 12. Negative 6 times 3 is negative 18. X times x is x squared. Negative 6 times negative 2 equals positive 12. Times x gives 12x. 12 times 3 is 36. Times x gives 36x. 12 times negative 2 is negative 24. At this point, we combine like terms. (12x) and 36x are like terms, so we can combine them to form a single term. 12x plus 36x is 48x. This brings us to the end of this lesson. Remember, practice makes perfect. Thanks for watching.